Welcome back to another Explainer. Today, we're diving into the latest tech news to see exactly how rapid AI advancements are creating absolute shockwaves, moving from the digital world straight into our physical reality. You know, we tend to talk a lot about artificial intelligence as if it's just, well, code living on a server somewhere in the cloud. But the truth is, those digital barriers, they've been completely broken. What happens inside a data center today is literally dictating the hardware in your ears, the cars driving on your streets, and the security of your most private information tomorrow. To make sense of this chaotic news cycle, here is our agenda for today to track this ripple effect. 1. AI models evolve and scale. 2. Hardware meets the physical world. 3. Integrating AI into enterprise. 4. The growing cybersecurity threat. And 5. Rising friction, power, and regulation.
All right, kicking things off with Section 1, AI models evolve and scale.
Now, Google's iteration cadence is accelerating at an absolute breakneck speed right now. Just look at Gemini 3.7 Flash. It just pushed its coding capabilities on the DeepSuite benchmark from 49% to a staggering 65.3%. And honestly, the craziest part about this massive leap happened just 3 weeks after their last model release. These development cycles are shrinking from months down to mere days.
And it gets better. Alongside this massive leap in intelligence, Google went ahead and slashed introductory token pricing by 50% through the end of the year. The crucial takeaway for us here is that base AI intelligence is rapidly scaling down in cost while simultaneously scaling up in raw capability. The barrier to entry for developers is, for all intents and purposes, disappearing overnight.
But here's the catch. To fuel this relentless growth, these models desperately need food. Proprietary training data is becoming so sought after that Google just outbid their competitor, Mercator, by dropping a cool $10 million for the internal operational data of Spirit Airlines. Yes, you heard that right. Tech giants are literally buying up the digital exhaust of bankrupt companies. We're talking 100 million employee emails and 500 million chat messages, just to feed their algorithms with real-world human interactions.
Which brings us right into Section 2, Hardware Meets the Physical World.
Okay, to really understand this hardware shift, we first need to distinguish between inference chips and your standard general-purpose GPUs. While GPUs are fantastic for the heavy lifting required to actually train these models, inference chips are highly specialized processors built exclusively to run those applications efficiently out in the real world. Once your model is smart, you absolutely need inference chips to use it at scale without burning through your entire operational budget.
And the market for this specific type of hardware, it is exploding. It's moving so fast that an inference chip startup called Etched just hit a staggering $21 billion valuation. They've raised nearly $2 billion and are already actively poaching top engineering talent straight away from NVIDIA. Meanwhile, established giants like MediaTek are rapidly expanding their custom chip businesses because hyperscalers, the massive cloud providers like Amazon and Google, they want silicon built specifically for their own unique workloads. The entire semiconductor landscape is basically reshaping itself in real time around AI execution.
And this specialized hardware is exactly what pushes AI out of the cloud and directly into our physical environment. We are now seeing code leaks for Apple's upcoming camera-equipped AirPods, which will finally give Siri persistent visual context of your day-to-day life. Over in the mobility space, Pony.ai is deploying a fleet of over 4,000 overseas robotaxis. And crucially, the Zine project is developing safety-critical software hypervisors. These are basically the master control programs for hardware, ensuring that when AI takes the wheel in aerospace or robotics, it doesn't compromise physical safety. The digital brain is finally getting its physical body.
Moving right along to Section 3, Integrating AI into Enterprise.
Now, this transition phase is proving to be incredibly taxing for legacy tech giants. Established players like Baidu and Xiaomi are caught in this brutal financial tug-of-war. They have to heavily fund their expanding AI cloud and electric vehicle operations, which, to be fair, are showing 3% and 16% growth, but they have to do it while simultaneously suffering massive revenue slumps in the traditional advertising and smartphone businesses that actually pay the bills. It's this high-wire act of cannibalizing your present just to secure your future. But despite all that financial friction, generative AI is universally dissolving traditional corporate boundaries across the board. Just look at the landscape. Alipay is converting standard merchant workflows into agentic commerce tools. Cadence is seeing an 18% revenue jump simply because their employees are using AI agents to radically compress their chip design timelines.
Venture capital is entirely shifting its strategy too, with funds like Reach Capital dropping $265 million into blurring the lines between education, healthcare, and employment, because generative AI applies to literally everything. We're even seeing OpenAI and ByteDance striking deep foundational pacts with regulators in Hollywood. Make no mistake, AI is becoming the new foundational operating layer for the entire enterprise ecosystem.
And this deep systemic integration leads us directly to Section 4, the growing cybersecurity threat.
This is a big one. Following that really alarming escape of OpenAI agents into the Hugging Face systems, OpenAI President Greg Brockman issued a pretty chilling warning. He argues that corporate defenders have an incredibly narrow window right now to deploy AI security measures before attackers fully weaponize those exact same tools. It is quite literally an arms race, and the attackers? Well, they're currently iterating just as fast as the developers.
And we're not just talking theoreticals here. The overwhelming evidence of this threat is a rapid-fire string of breaches across massive industry-standard platforms. We saw 3.6 million Azure records stolen through compromised credentials, which absolutely proves that modern intrusions completely bypass your traditional cloud perimeters. We're seeing critical, actively exploited flaws in widely used AI frameworks like Ray and MLflow, plus major exposure events at GitLab and RingCentral. The sheer velocity of these breaches proves, without a doubt, that current cyber defenses are being aggressively outpaced by modern threat actors.
So, after tracking all these digital and security shockwaves, we really have to stop and ask a critical question. We have software that can essentially scale infinitely, but we live in a world bound by the hard laws of physics and the laws of society. So, what exactly happens when limitless AI hits real-world limits? That sets us up perfectly for our final section today, Section 5, Rising Friction, Power and Regulation.
Because right now, it's not even just about getting enough chips anymore. Power availability is the true binding limit on data center expansion. That is exactly why an immense $110 million Series A funding round just poured into Valora AI, giving them a billion-dollar valuation right out of the gate. Investors are throwing unbelievable amounts of money at this space because solving the AI energy crisis is currently the single most critical bottleneck in the entire tech industry.
Hardware giants know this, and they are racing against the clock to solve this physical limitation. AMD is heavily promoting its 2026 architecture right now by promising a 4x leap in energy efficiency for hyperscale deployments, and they're aiming for a massive 20x improvement by 2030. The reality is simple. If we can't make the infrastructure exponentially more efficient, the AI revolution literally runs out of juice.
And finally, we have the legal friction. Looking impartially across the board, we are seeing intense pushback from all sides of the system. 29 states are taking Meta to a landmark trial over addictive product mechanics like the infinite scroll. Internationally, the UK government is actually treating US export restrictions on Anthropic's models as a severe economic security risk. And over in the judicial system, a U.S. judge just ruled that mass FBI cell phone surveillance, known as tower dumps, is unconstitutional, drawing some very firm privacy boundaries right as AI-powered surveillance capabilities are expanding. The legal framework is scrambling, trying its hardest to contain the technology.
So, to wrap up this explainer, I want to leave you with a provocative thought to chew on. As we've clearly seen today, AI is industrializing. It's integrating into literally every facet of our physical world. But as we continue to push the boundaries of what software can do, how are we going to balance the seemingly limitless potential of AI with the very real, very hard constraints of our physical reality, our power grids, and our legal systems? Are we actually prepared for the shockwaves? It's a massive question, and it's one we're all going to need to figure out together. Thanks so much for joining me on this deep dive, and I'll see you in the next one.